All right, AP Chemistry. This is the second part of that podcast because I didn't get a chance to finish it. Okay, so where we finished was we said that we had 18 grams of HgBr2 that was produced from 10 grams of mercury and 9 grams of bromine. Okay, and question B is just an extension of that. It says if the reaction did go to 74.3% completion, how much of the excess reagent would be left over? All right, so we need that equation back. Hg plus Br2 gives us HgBr2. All right, and it's all balanced and good to go. So the next thing says we made 18.0 grams of HgBr2. Okay, so it says if the reaction did go to 74.3% completion, how much of the excess reagent would be left? Well, that's where we know that, we didn't make this. This is what we should have made, right? So this would be our theoretical yield. I had to backtrack for a second. This is how much we should make if we reacted these two reactants with that amounts together. Okay, but we know we only did 74.3% of what this should be. So what would be our actual yield? Well, we take this and we plug it into percent yield is equal to actual yield over theoretical yield. Oops. Okay, so we plug this in. This is our theoretical yield, and this is our actual yield. So if we take 70, or not actual yield, percent yield. I'm all over the place. Sorry. I know what I'm saying. It's just not coming out right. Okay, so percent yield goes in for percent. Actual yield is what we're looking for, and the theoretical yield is 18.0. That's how much we should make if it's a perfect world. Okay, so we plug it into this equation, and now we're going to solve for actual yield. So we divide both sides by 100, so 0.743 is equal to the actual yield over 18.0 grams. We're going to multiply both sides by 18.0 grams, and we're going to end up with an actual yield that's equal to 13.374 grams. So that's how much HgBr2 we will make if the reaction only goes to 74.3% completion. Okay, because remember, no equation and nothing is actually perfect and will it go through all the way. All right, so this is how much we will make, or we did make. And then we have to go backwards. So saying if we have 13.37 grams of HgBr2, how much of the excess reagent is left over? Well, remember, if this one's the limiting reagent, this means this one is the excess reagent. Okay, so we've got 13.374 grams of HgBr. So we've got to set up our rights table. Excuse me. We're going to take this 13.74 grams, we're going to change it into moles. Okay, 1 mole goes on top, and then we multiply by the mass of HgBr2, which happens to be 360.39, and we end up with 0.0371 moles of HgBr2. Okay, so that's how much we ended up making, 0.0371 moles. Okay, now some people are confused. They say, well, how do I know if I put it on the top or if I put it on the bottom? Well, remember, if it's on the product side, the moles goes on the bottom. If it's on the reactant side, the moles goes on top. Why? Because we never start with any of our reactants or any of our products. Okay, and the change is a plus 1x. Okay, and we're looking for our reagent or for our bromine, and it says, hey, you use we're looking for how much of that reacted. We know that we're going to react with a change of negative x, and we're going to use all of it. Okay, because we're going to have some left over. So how much do we use if we're going to react this? Okay, so when we solve for x on this side, x is equal to 0.0371. When we plug this in here, we end up with 0.0371 moles. And then we take that number, 0.0371 moles, and we multiply it by the mass of bromine 2. Okay? The mass of 2 bromines is 159.8 grams over 1 mole. Moles cancel. And when we do our math, we end up with 5.928 grams of Br. Now that's how much of the bromine we are going to use. All right, but we started with 9 grams of bromine. So if I subtract those, I should be able to figure out how much is left over. 3.072 grams of Br2 left over. All right, lots of steps, right? Yep, lots of steps. Okay, on the next one. Okay, last one here. Commercial brass is an alloy of copper and zinc. It reacts with hydrochloric acid by the following reactions. However, if you'll notice in there, it's just the zinc that's reacting. Copper does not react with hydrochloric acid. All right, so what if we took a sample of 0.5065 grams of brass and react it with excess HCl? Okay, when we do that, we're going to make 0.0985 grams of zinc chloride. I want to know what's the percent composition of the brass. All right, well, we know that we have, let me get my pen. We know that we have this equation, Zn plus 2HCl, ZnCl2 plus H2. Okay, we know we have this equation and it's balanced. Okay, now this number right here is for brass. And we don't have brass in our equation, so we cannot use this number here in our rice table because it's not for zinc. Okay, even though this says that it's a sample that has zinc in it, it's not the number for zinc, so we cannot plug it in here. Okay, but we do have this number here, which goes with zinc chloride, and we have zinc chloride here, so we can plug that in, and we'd have to change it from grams to moles, and we divide by the formula mass, and so we would end up with 6.03 times 10 to the negative fourth moles. Now I'm leaving it in scientific notation so I don't have a bunch of zeros at the beginning. If you take it out, that's your choice, but you better keep track of your zeros. All right, and they want to know what is the percent composition of the brass. Well, if I'm starting with zinc chloride, it's not going to help me to find the moles of, or the anything that has to do with hydrogen. I don't think it's going to help me if I do anything with hydrochloric acid, but I think that if I find zinc, that'll help me find my percent composition of the brass because brass has copper and zinc in it. Okay, so we're going to start off, here's our rice table. Okay, I don't know how much of this I'm starting with, so that's what I'm looking for. My change is negative x, and I'm hoping I'm going to use it all and get rid of it all. Okay, and then on this side, remember we start with 0. The change is going to be a positive x, and I'm going to make 6.03 times 10 to the negative fourth moles. Okay, so when I solve for x, x is 6.03 times 10 to the negative fourth. I'm going to plug that in there, which is going to give me 6.03 times 10 to the negative fourth. And that's how many moles of zinc I will make, or I'll use. But I don't want moles, I want grams. Okay, so we're going to take that 6.03 times 10 to the negative fourth moles. I'm going to multiply it by the mass of zinc. Okay, so 1 mole and 65.41. Okay, and when we do that, the mass ends up being 0.03945 grams of zinc. Okay, so that tells us how much zinc we've just reacted from this brass sample. And then we'll know the percent composition of the brass. Well, in order to find percents, you take the part over the whole. So if we take that and we divide it by the whole percent, or the whole mass, 0.5065 for the brass, I should be able to find the percentage of zinc in the brass. Okay, so if I do that, I end up with 7.789, which becomes 7.79% zinc. And then to find my percentage of copper, well, 100%, if I subtract that, I'll end up with 92.21% copper. Okay, and that's how you would find the percent composition of the brass. All right, guys, that's it. So hopefully you got all that, and I'll see you in class. Bye.